given a relation P is equal to set x comma y such that mod of x square plus y square is equal to 1, where x and y are real numbers, then we need to identify that whether this relation P is reflexive, symmetric, or transitive or antisymmetric. So reflexive definition says for every A belongs to, here the set is R, A comma A must belongs to the relation P. So here the relation is P. Let's take an example. For 1 is a real number, 1 comma 1 consider ordered pair 1 comma 1. So which implies 1 square plus 1 square mod, which is equal to mod 2, which is not equals to 1. So that we can say 1 comma 1 does not belongs to the relation P. Since for a real number 1 belongs to R, 1 comma 1 does not belongs to P, means we can conclude that this relation is not reflexive. And coming to the symmetric, the definition says for A comma B belongs to the real numbers. If A is related to B, that is A comma B belongs to the set P, then B comma A must belongs to the set P. So here we can consider for let us take A comma B belongs to B, or X comma Y belongs to P. So which implies x square plus y square is equal to, or mod of x square plus y square is equal to 1, which can also be taken as mod of y square plus x square is also 1. So which implies that y comma x is also belongs to set P. So for x comma y belongs to P, y comma x belongs to P, for x and y are real numbers, we can say that this relation is, so the relation P is symmetric. So we can say symmetric is the answer, and let us also check for the transitive. Transitive definition says for A comma B comma C belongs to some real numbers here. If A is related to B, that is A comma B belongs to P, and B comma C belongs to P, then we can say that A comma C must belongs to the set P. So if A comma B belongs to P, which implies that, let us consider, since x square plus y square is equal to 1, it is a unit circle. We can mention like it is a unit circle. So the points can be taken here 1 comma 0, 0 comma 1, or minus 1 comma 0, and 0 comma minus 1 points. These are some points on the coordinate axis. So let us assume like 0 comma 1, 0 comma 1 belongs to P, which satisfies, that is mod of 0 square plus 1 square, which is equal to 1. And also 1 comma, let us consider 0. Let us consider 1 comma 0 belongs to P, which implies mod of 1 square plus 0 square is equal to 1. But when we consider 1 comma 1, 1 square plus 1 square is equal to mod 2, which is not equals to 1. So we can say for 1 comma 0, for 1 comma 0 belongs to P and 0 comma 1 belongs to P. So but 1 comma 1, 1 comma 1 does not belongs to P. So let me write here. For 1 comma 0 belongs to P and 0 comma 1 belongs to P, which implies 1 comma 1 does not belongs to P, and hence we can say the relation P is not transitive. And coming to the antisymmetric, antisymmetric definition says if A comma B belongs to the for A and B belongs to real numbers, if A comma B belongs to the set P, that is relation, and B comma A, B comma A also belongs to the relation P if and only if it is possible only when A is equal to B. But here in the case of symmetric, if I take an example, 1 comma 0, already we have proved here, 1 comma 0 belongs to P and 0 comma 1 is also belongs to P. So we can say that it is transitive symmetric if 1 comma 0 belongs to P and 0 comma 1 belongs to P, but it doesn't mean that 1 is equal to 0. So 1 comma 0 belongs to P and 0 comma 1 belongs to P, which does not imply that A is equal to B, that is 1 is equal to 0. And hence we can say that this relation P is not antisymmetric. So and hence we can go with only option B. Symmetric is the answer.